through doing several years of research, I came to the conclusion that this nutrient might be one of the most common and overlooked nutritional deficiencies, which can contribute to a lot of different health problems, but that not many people really know about or talk about. There's an assumption in conventional medicine that most nutrient deficiencies are not prevalent or not really found in any significant degree in the modern world. So in first world countries, this is a thing of the past. However, if you deeper into the literature and you work with people in clinical practice, then you begin to see that actually it couldn't be further from the truth, especially in the US. The US, I've had a lot of clients that I've worked with over the years in the US, has a tendency to consume vast amounts of processed food. And the reason why that's important, and just cut me off if you want to, I'm going off on a tangent, by the way, but the reason why this is important for any of your listeners, if someone has a tendency to consume processed food, remember what I was talking about, you have the macronutrients, so protein, fat, carbohydrate, but you have your micronutrients. And you need your micronutrients, so your B vitamins, your minerals, you need those to process the stuff coming from carbohydrate and fat and protein.
Elliot Overton, thank you for joining me on the podcast today.
Thanks for having me on, Les. It's great to be here.
I'm pumped to talk to you. I've digested quite a bit of your content over the last several years. A lot of it associated with oxalates and learning about that as I was navigating some weird health issues around that. And I know I wasn't alone with that. There's a lot of people that have to navigate weird stuff with those. And learning more about different vitamins and nutrients. And your channel is EO Nutrition. Is that?
Yeah, that's correct.
I've watched you kind of build that up over the last few years, and really deservingly so. You have a great way of communicating and providing really education for people that are, I guess, trying to be their own advocate and trying to figure out their health journey, many of which have probably been let down a little bit by the more traditional like health structures, if you will. And I mean, you've just been a great resource. So I appreciate and I'm grateful for the work that you've put in to get your message out there.
Thank you. Very nice words.
I was hoping over the last couple years, I've been learning more about metabolism in a more general sense, and learning how so much of our daily functions through all the different systems in our body all kind of share. It's like you have this network of systems that are all intertwined. But at the center, you have this energy system that they all tap into and rely on. And for things to go well all over, then you need like an abundance for that. And I guess there are potential bottlenecks that could be driven by many different things. It seems like maybe there's some genetic factors. There's clearly like lifestyle factors. I know, for instance, I was drinking alcohol basically daily for a long time. And that probably hindered me in my ability to make energy. But the idea of taking the food that we eat and making an abundant amount of energy out of it so that the inner wisdom in our body could do all the things it wants to do is kind of like central to all of our like health outcomes, if you will. And one thing that you've been a real advocate for is this basic nutrient, thiamine, vitamin B1. And I know it comes in different forms, and maybe we can get into that. I was hoping you could start off, because I don't know how much my audience is really familiar with this, is giving maybe just a little thiamine 101, if you will, and maybe how you stumbled upon it.
Yeah, of course. And really, it's building on what you just said as a foundation, really. This concept that disease, or let's say a lot of the research into the development of different diseases over the past several decades there used to be a focus on genetics. And so you would hear if someone got cancer, if they had any kind of neurodegenerative condition, any condition which can significantly impact someone's quality of life, any autoimmune condition, any condition which has potentially fatal consequences. When we're talking about chronic health conditions, a lot of the research used to be focused on genetics. So the genetic blueprint that you're given from your parents, how that predisposed you towards disease. And there's been a major shift, like I said, over maybe the past 20, 30 years. Rather than looking at genes as the determining factor, rather this concept of or looking at other factors which can predispose someone to disease. And I think that the research is heavily focused on now is this concept that disease in many respects stems from a lack of usable energy at the cellular level. What do I mean by that? Well, each one of your cells are like, they have lots of different organelles, they're called, but they're like little structures inside the cells which do different things. So you have your nucleus, which has DNA and that holds your genetic blueprint. You have ribosomes, you have all of these different structures. But one of those structures, perhaps the most important structure, is called the mitochondria. And you can think of this a little bit like an energy factory in each of your cells. And what they found is that in different types of diseases, when those mitochondria no longer function in the way that they need to function, as in allow you to take the energy from food, convert that into usable biological energy, and then put that to use inside cells, they found that when cells lose the ability to do this, generally that correlates very closely with disease. And depending on where this occurs in the body is going to determine where the disease will present. And I'll give you an example. So in the brain, if you were to look at something like Alzheimer's disease, which is extraordinarily common in the USA these days, Alzheimer's disease tightly correlated with the production of usable energy in the brain. There's a doctor recently came out, he wrote a book called Brain Energy. I can't remember exactly what his name was, but he's introducing this concept, although it's been known for a very long time, that ultimately Alzheimer's disease is caused at its root. There may be other predisposing factors, but it's caused at its root by a lack of usable energy in the brain, and so the disease presents in the brain. On the other hand, if it occurs in the liver, well, someone has liver disease, and that can manifest in lots of different ways. If it's in the skin, well, they might present with psoriasis or skin rashes or some other kind of inflammatory disorder of the skin. So wherever you see a lack of usable energy, or in research terms, it's called mitochondrial dysfunction, when those little energy factories inside the cells don't work and they can't make energy, then your cells can't do what they need to do. Okay? It's as simple as that. And if they can't do what they need to do, then they stop functioning. And so it's kind of shifting our framework rather than looking at things that you can't change, being your genetics, rather what can you change and what is the fundamental cause of disease and how can you address disease? Well, it comes back to improving energy. Like I said, those conditions that we've spoken about, in those conditions, if you can improve the rate at which the mitochondria are using energy or manufacturing energy, then you can improve the disease. And that is not it's an unconventional standpoint from a traditional medical perspective. However, that it's accurate. It's factually accurate to say that can occur. So that was a long-winded way of answering the question. What you're asking about is vitamin B1. So for your listeners, for those factories to make energy inside the cells, you need what are called micronutrients. So in the food that you eat, you may have heard of nutrients. In the food that you eat, you get the energy in the form of carbohydrate, fat, and protein. However, what's perhaps more important is to be able to obtain that or utilize that energy contained within those macronutrients. You need micronutrients. So this is your minerals. Most of your listeners probably heard of iron. They're familiar with zinc, calcium, magnesium. These are all micronutrients in the mineral category. But we also have the vitamins being the B vitamins, vitamin C, etc. Now, the reason I'm emphasizing this is because these are the tools that you use. In simple terms, I'll give you an example. If you were to eat carbohydrate, to be able to utilize that, you have to break it down. And you have to break it down via several different steps. So you don't just take the carbohydrate and consume that as energy. No, you have to break it down like several different times. And you do this through different enzymes. And each of those enzymes requires these micronutrients. Okay. Now, you mentioned thiamine. Well, I developed a particular interest in thiamine because it was the first vitamin to be discovered. It's otherwise known as vitamin B1. And I think it's perhaps the most important nutrient for how you are processing energy or how you're making energy in these energy factories. And it's tightly correlated with carbohydrate consumption. So in other words, the more glucose or the more carbohydrates that you consume, the greater demand you have for this vitamin. It's also very difficult to test for. And so through doing several years of research, I came to the conclusion that this nutrient might be one of the most common and overlooked nutritional deficiencies, which can contribute to a lot of different health problems, but that not many people really know about or talk about. There's an assumption in conventional medicine that most nutrient deficiencies are not prevalent or not really found in any significant degree in the modern world. So in first world countries, this is a thing of the past. However, if you dig deeper into the literature and you work with people in clinical practice, then you begin to see that actually it couldn't be further from the truth, especially in the US. The US, I've had a lot of clients that I've worked with over the years in the US, and the US has a tendency to consume vast amounts of processed food. And the reason why that's important, and just cut me off if I'm going off on a tangent, by the way, but the reason why this is important for any of your listeners, if someone has a tendency to consume processed food, remember what I was talking about, you have the macronutrients, so protein, fat, carbohydrate, but you have your micronutrients, and you need your micronutrients, so your B vitamins, your minerals, you need those to process the stuff coming from carbohydrate and fat and protein. You need to be able to use those in the body. You need enough vitamins and minerals. Now, when you process a food, like in the US, you take sugar cane, but then you process it into white sugar. What you do, if you look at sugar cane, it naturally contains, like most whole foods, really any whole food that you find, it's going to contain its own ratio of vitamins, of minerals, and whatnot. But when you process that, you either heat it to a very high temperature or you put it through some kind of a chemical process. What you do is sugarcane, for instance, you take out the pure glucose or the pure sucrose, the pure sugar, but you lose all of those micronutrients. So what can happen is that if you consume this, you produce this imbalance or a disbalance where you've got lots of this energy coming in, but you're not matching that with the amount of micronutrients that you need to process that energy. So when this happens for long enough, what we see is this tendency to mitochondria losing the ability to make energy because they don't have enough of these micronutrients. And when you see this lack of ability to make energy, you see various diseases start to manifest. And that's why nutrient deficiencies can and probably are involved in most of the diseases that plague human beings to this day, at least chronic diseases.
Yeah, thanks for that. Yeah, I think most people have probably heard this term mitochondrial dysfunction, and it's like association with everything, but they don't necessarily understand what that really means. And at the core of that is you're just not making enough energy. It's just not performing optimally, and there's different insults that can drive that. But one thing that you talk about is this like bottleneck, I guess, especially with carbohydrates, and I guess I want to learn more about its role with fat. Also, is you need to get. So when we eat a carbohydrate, it's broken down, whether it's like a sugar or a starch, it ultimately gets broken down to glucose, which is like our cell's favorite thing to run on, essentially. And stop me if I'm wrong, but it's like 6 carbons long. It splits up through glycolysis into pyruvate, which is like just half of glucose. And then it has to get inside from that point into the mitochondria to make best use and best energy. And that is one of those bottlenecks where thiamine plays a role. Can you describe its role in that phase and how that gets thrown off? And what happens like if there's not enough thiamine to get that pyruvate in, like what takes place instead?
Yeah, okay. So when I said that thiamine needs to be matched, that your amount of thiamine intake needs to be proportional to your carbohydrate intake. The reason for that is because various steps at which, like you said, so when you consume anything containing carbohydrate or glucose, if it's carbohydrate like a starch, what will happen is your digestive system will break that down. So it will break it apart to produce pure glucose, okay? And you'll be absorbing pure glucose into the blood. Now, glucose gets into cells through glucose transporters. And then inside cells, outside of the mitochondria, like you said, it enters into a process called glycolysis. Glycolysis, again, it's essentially breaking apart glucose into more simple molecules. Those are pyruvate. Now, pyruvate has several different fates, but what it's meant to do is it's meant to get shuttled into the mitochondria. When it enters into the mitochondria, there's an enzyme called pyruvate dehydrogenase. Pyruvate dehydrogenase converts pyruvate into a molecule called acetyl coenzyme A. Now, acetyl coenzyme A then enters into what's called the Krebs cycle or TCA cycle. And then what you're doing is you're gradually tearing that apart and you produce these redox molecules, which are NADH and FADH2. Again, I don't know how deep to go into the biochemistry because it's probably not going to mean anything for your audience, but essentially,
I don't know who listens to this.
I don't know.
I've never met any of these people, but I'm interested. Keep going.
Okay, yeah. So it's entering into the TCA cycle. Now, the TCA cycle is, again, it's in the mitochondria, and that's a process that's not unique to glucose metabolism. Okay, glycolysis is unique to glucose metabolism. TCA cycle is essentially just how you are converting acetyl coenzyme A, tearing that apart to make NADH and FADH2, which are then going to be shuttled into the next phase of energy metabolism, which is the electron transport chain. And that is essentially 4-5 steps before you can make ATP. All of this is with the purpose of making biological energy in the form of ATP. Okay, all of this.
Does thiamine? I'm sorry. So thiamine plays this role at this enzyme pyruvate dehydrogenase. Did I say that right?
Exactly.
Does it play any roles in that last cycle, that electron transport chain?
Not directly. However, okay, we'll go into some more detail if you want. As part of this process of taking pyruvate and then shuttling that into the mitochondria and then breaking it down further, there are what are called rate-limiting enzymes, okay? So just imagine that you've got lots of these different cogs in the machine, okay? And once pyruvate's getting into the mitochondria, then it is going through, it's being transformed in numerous ways through all of these different cogs. Now, some of those cogs, these enzymes, are referred to as rate-limiting enzymes, meaning that if they are not functioning or they do not convert, they don't act on the substrate that they need to act on, when they slow down, every other step following it also slows down, okay? So basically, if those enzymes don't work, then energy metabolism grinds down to a halt or it slows down. It means rate limiting, it means it limits the rate of the entire process of making energy. So these are really important. Now, it just so happens that the 3 or 2 of the key rate-limiting enzymes in energy metabolism are the dehydrogenase enzymes, which are dependent on thiamine. If you don't have enough thiamine, then those enzymes slow down. You can't make energy. Full stop. It doesn't matter if you have other nutrients. If you don't have enough thiamine, then the entire process is gonna be blocked. Now, so pyruvate dehydrogenase is one of those, and this is why thiamine status is considered rate-limiting for carbohydrate metabolism, because when you're taking energy from fats or proteins, they're entering into the TCA cycle. They enter into the mitochondria and the TCA cycle through a different route. So you don't make pyruvate from fat. You don't make pyruvate from protein. That's purely carbohydrate.
But you still can make acetyl-CoA.
You can, exactly. You do it via a different mechanism. So you still make acetyl-CoA. So whatever you're doing, the fate of fat, protein, protein is entering it in. You can, but it's entering in at a different spot. But without going into too much of the details, whether it's fat or protein, you're still making that same raw material, which is acetyl-CoA, which will go through the exact same TCA cycle, regardless of its origin, okay? But coming back to pyruvate, you don't have enough thiamine. One of the first enzymes to slow down is pyruvate dehydrogenase. So then what you end up with is a backlog of glucose, a backlog of pyruvate. Now, what ends up happening in that situation is that pyruvate needs to go somewhere, and there's various reasons for that, but bad things happen if you get a buildup of pyruvate in the cell. So, as an alternative, the cell is going to direct or reroute that pyruvate towards lactate. Lactate, your listeners might be familiar with if they do intensive exercise. Lactate is going to be the thing that builds up in the muscles that causes a burning sensation. Though there's debate about that, but think of it in a simplified way. Lactate is a metabolic byproduct, a waste product. We're always producing small amounts, but when you lose the ability to get glucose, subsequently pyruvate, into the mitochondria, then that occurs at a much greater rate. It goes on, it's like lactate production on steroids. And this is one of the reasons why people who have thiamine deficiency, end-stage thiamine deficiency, will develop lactic acidosis. That's where there's so much lactate that it's actually being pumped into the blood at such a higher rate. And when you do a blood test, you see very high levels in the blood, and that can cause all kinds of different problems, all kinds of physiological issues, and it can kill people.
Is that what the Warburg effect is?
Yeah, basically. That's what the Warburg effect is. Now, the Warburg effect can actually be counteracted by a molecule called dichloroacetate. And when they administer dichloroacetate, if I remember correctly, dichloroacetate is a pyruvate dehydrogenase kinase inhibitor. So you have an enzyme which basically turns on and turns off pyruvate dehydrogenase. Now, in cancer cells, it's turned off, which means that the Warburg effect is basically when cancer cells take glucose and they just run it through glycolysis all of the time. So there's a lot of lactate being produced, and there's it's basically, the definition is an impairment of mitochondrial energy metabolism. That's why they suck up glucose and they consume it in such high rates. So that is exactly what the Warburg effect is. However, the Warburg effect occurs even when there is the presence of oxygen. So what I haven't said is that this role of turning on and turning off pyruvate dehydrogenase is functional. What I mean by functional, it happens normally when cells don't have enough oxygen. So to use or to make energy in the mitochondria, that's the primary purpose why we need to breathe oxygen, is because that final step of making ATP, it depends on oxygen being present. So if cells don't have oxygen, they still need a backup route to make energy. And they do that via this process of anaerobic glycolysis. Anaerobic means without oxygen. And what the cell will naturally do, if it detects that there's hypoxia or detects that there's a lack of oxygen, it will switch off pyruvate dehydrogenase because the mitochondria can't work that way. Okay, it requires oxygen. So it's like, okay, if we don't have oxygen temporarily, what we're going to do is we're going to rapidly metabolize as much glucose as we can so the cell doesn't die because of a lack of energy. Does that make sense?
And that's what happens like during exercise, where the demand of energy increases and your body has this emergency system, this backup system to allow the supply of energy to meet the demand.
That's the thinking, yeah. Now there's other mechanisms. There's like the creatine, so phosphocreatine you can use, but yeah, that's the concept. Is one of the reasons why when you do exercise, your breathing rate increases. Because you need to supply, because your cells have such a high demand or turnover for energy, they require a greater concentration of oxygen. And so your breathing rate increases so that the oxygen can travel around the body and go to the cells so that you can continue making energy, because when you use your muscles, you have a high rate of ATP turnover. Okay? So your mitochondria gets placed under stress, you need more energy, and therefore you need to breathe more oxygen. However, in the context of thiamine deficiency, well, that will occur even if you've got enough oxygen. You see what I mean? So it's kind of like you're exercising, you have a high rate of demand on metabolism, but if you're deficient in thiamine, well, you can't burn that energy or you can't utilize that energy. And to be clear, just so your listeners know, there's a major difference. Your listeners might be thinking, well, if you can just make glucose from glycolysis and turn it into lactate, why don't you do that if that provides energy? Well, for reference, in the mitochondria, you make substantially more, like 15 times more of the amount of ATP than you would through glycolysis. So glycolysis is extremely inefficient. It is by no means a useful way to, it's basically like a last-ditch effort, a backup mechanism to prevent cells from dying, right? But it's by no means it's an emergency system and is highly inefficient. To make energy in a clean, efficient way, in a way that is actually a good allocation of your resources, you want to be doing it in the mitochondria. So we have this system to burn glucose, and this is dependent on B1. But it gets even more interesting, because if you look at the second, perhaps what's considered the rate-limiting enzyme for the TCA cycle, this isn't just important for glucose. This is also important for fat and protein metabolism as well. So people are going on a ketogenic diet and they say, well, actually, B1 might not be very important for me because, I'm making a lot of energy from fat and therefore my B1 requirement is less. Well, that's technically true. If you look at the biochemical pathways, people who don't consume carbohydrates might just require, approximately 50% or, a little bit less, a little bit more of thiamine, because you don't need as much because you're not consuming as much glucose. However, even when you consume fat, you still make acetyl-CoA. And acetyl-CoA is being fed into the TCA cycle. So the rate-limiting enzyme for the TCA cycle is called alpha-ketoglutarate dehydrogenase. This also depends on vitamin B1. If you look at a lot of the conditions which we use high-dose thiamine for in clinical practice, many of them, if you look in the research, there is some kind of an impairment in this enzyme complex. And so for this reason, by giving high doses of B1, you can actually increase the rate at which this enzyme works, and you can reignite energy metabolism. Now, a lot of diseases have shown that when you block the activity of this enzyme, you cause a dramatic reduction in ATP, in energy, usable energy. So it's like, it doesn't matter, you said that the final step, electron transport chain, it doesn't matter if that is fully functional. It doesn't matter if you have all of the other nutrients which are used by the other enzymes. If you block alpha-ketoglutarate dehydrogenase, which is a thiamine-dependent enzyme, if you block that, massive problems occur because of widespread mitochondrial dysfunction. So this, I think, is probably the single most important enzyme for central energy metabolism across the board. And partly because it's used as a sensor. We're going quite high level here. I hope that's okay, but you asked for it. So basically, it's considered what's called a redox sensor, and it's responsible for determining not only the flux of energy coming in from outside into the cell, and therefore controlling the rate of metabolism in the mitochondria, but it's also responsible for detecting levels of oxidative stress it's referred to as, it's basically involved in gene expression. So whether it increases the rate of metabolism or decreases the rate of metabolism is going to have various knock-on effects on calcium signaling, on all these different signaling mechanisms, which affect basically every single function in the cell. And for this reason, it's been referred to as a mitochondrial redox sensor. It really is a super interesting enzyme. And because of this, they are looking at this enzyme as a target, a therapeutic target, in things like neurodegenerative diseases, in other types of diseases, CFS, Alzheimer's, whatnot. So there's a lot that goes on.
That's really interesting. I really enjoy some of that nerdy stuff. Can we dial it back a little bit, a different direction? Do you mind?
Of course, yeah, that's fine.
You need thiamine not just for the carbohydrate, because of those later stages, the other enzyme, alpha-keto...
Glutarate dehydrogenase,
okay.
yeah.
Before that, though, to get into the mitochondria, which is this first, I guess, really important step to avoid this lactate production and this inefficient energy where you're making 1/15 the amount of ATP. I've heard you reference that when you eat like a high carbohydrate diet that doesn't have the abundance of corresponding micronutrients, which probably happens a lot for many reasons, not just because of the standard like processed food, but maybe depletion in our environment that we're getting food from, or farming practices or whatever. And in general, too, vitamins and minerals are just oddly overlooked. But every pathway, like every process in the body is some kind of pathway. And like it seems like at every step of every pathway, there's some kind of vitamin and or mineral that takes it to the next step. But you mentioned that in that state where you have a heavy amount of carbohydrate without these corresponding nutrients, that the enzymes, like the machinery, can slow down, which makes sense because, if you don't, use it, you lose it kind of thing would correspond with a lot of other bodily functions or adaptations. I had a question that I haven't really heard you mention. What about the other end of the spectrum? So, I went low carb for a long time, and a lot of people go low carb for all kinds of reasons. Can that machinery slow down, and because you're not running it because you're just not eating a lot of carbs, and then if you go to introduce carbohydrates, the machines are all inhibited?
Yeah, so that does happen. That happens as a natural function of healthy metabolism, right? And that's one of the things that they refer to as metabolic flexibility. So if you look at the problem in say, diabetes, you'll see that they have an issue with bouncing back and forth from burning fat to burning carbohydrate. A healthy person should be able to burn carbohydrate when they consume it. So the rate at which you burn fat and carbohydrate depends on the time of day, depends on your last meal, depends on your activity. But in general, even if someone eats a high carbohydrate diet, they are going to be burning fat for a significant portion of the day. At nighttime, at rest, most of the time you are burning fat. And your cells should be able to flip back and forth depending on the amount of energy that they're being provided in the blood. So, to give you an example, if you drink a big fizzy sugary drink, that's going to spike your blood glucose, and then what should happen is that's taken up by cells. You burn that, and then you switch back to burning fat. Now, if someone goes onto a low carbohydrate diet, for instance, I think part of the reason why they feel so bad for the first couple of days is because their system is having to adapt to that. So first of all, it thinks you're in starvation mode, but then as you start to get adapted, or after a couple of days, you will start generating ketones, and they call it sometimes keto flu, or they say, for instance, if you are on a ketogenic diet, or if you're coming from a long-term carbohydrate-based diet, then it can take, a couple of weeks for your metabolism to start getting used to the idea of burning primarily fat for energy. Okay. Now, you're always going to be burning some carbohydrate, and that's going to be coming from wherever, if it's from the diet, or if it's from protein, if it's from your own protein, as in your muscle cells, or if it's from amino acids that you're getting from the food that you eat. You can convert that to glucose, and you can use that. So you're always burning both to some extent, depending on the type of cell. But to answer your question, it's a real thing, and it does happen. However, the concept of kind of those enzymes being shut down, and then specifically what were you asking? So the enzymes are inhibited, like your carbohydrate machinery is inhibited when you're on a low carb diet, right? That's what you're saying. But then if you shift, can they remain in that state?
Right. So I guess I was trying to juxtapose this with something I have heard mentioned, where if you eat a bunch of carbs and you don't have the corresponding nutrients, especially like thiamine, that you get that backlog that you referenced earlier, like you're not getting glucose efficiently into the mitochondria. That machinery gets like dumbed down, I guess, because it doesn't have the micronutrients to run that machine, to turn the cogs, I guess. And what I find in like the health sphere, I guess a lot of people go low carb for a lot of reasons, and a lot of them do really well, and some people do really well until they don't, and then they wind up reintroducing carbohydrates. And I have experienced that myself. And I guess initially when I did that, I felt like I was putting a lot of heavy logs on a low burning fire and smothering the fire a little bit. And ultimately, like, I feel like it's been a really positive thing to do, and I feel better in many ways. And I think overall my metabolism just feels better. My stress is much better. But I also wonder, because sometimes I feel like I don't make good use of those carbohydrates. And I wonder if like going low carb for so long also turn down those, like the fire in those cogs. And then when I introduce them, it's like, we don't know how to run anymore. We don't know how to turn these cogs. And can I jam those cogs with thiamine to turn them back on? Sometimes it feels like, because I've been tinkering with thiamine, one of the reasons I wanted to reach out to you. And I feel like there's a positive thing from it. So I'm trying to understand, like, is that what's going on? Did I get a fire burning too low with the lack of carbohydrate, and then try to force it up with too much wood?
In reality, that's exactly what we see. Now, mechanistically, I don't know exactly how that occurs. I can speculate, but anecdotally, there are countless people who say the same thing. It occurred with myself as well. I was not only long-term keto, I was keto for about 4 years when I started studying nutrition. So that was back in like 2014. Keto for many years, and then shifted to carnivore after that. And I see usually guys, oftentimes it's guys, but also some women, especially if they're of childbearing age. they notice that they benefit from adding in carbs, but it takes them a while to start really burning that fire, let's say, really increasing the rate of metabolism. Now, I think there's lots of ways in which someone could potentially explain why that occurs. If you look at the work of Ray Peat, he was heavily focused. Are you familiar with Ray Peat? Yeah, of course. So his kind of bioenergetic model, he focused heavily on the endocrinological aspect or endocrine aspect, so hormones. So that way he would be looking at thyroid, cortisol, all of those things. And he presents a pretty good argument that the greater amount of stress that someone is under is going to place a burden on those hormone systems. And he would refer to as fat-based metabolism as a kind of hormonal stressor. And so theoretically, what the body will do is reduce the production of thyroid hormone. There does seem to be pretty solid evidence that at least in some people, their thyroid hormone will reduce with long-term carbohydrate reduction. And so one of the mechanisms by which someone, after reintroducing carbohydrates, it might take them a while to start properly burning them at a greater extent and feel, actually stoking the fire, so to speak, of metabolism. It could be due to thyroid. It could be due to a reduction in stress hormones. At the mechanistic level, hypothetically, I would imagine that if you look at the enzymes, enzymes are coded. And if you're not using enzymes to the extent that, like, if enzyme activity, like let's say pyruvate dehydrogenase, I'm not sure the exact expression of this. I'd actually be interested to look at that. Maybe I will look at that. But I think that on a low carb diet, pyruvate dehydrogenase, the expression of that enzyme is reduced. Okay. And so it might take a couple of days of eating carbohydrates and stressing that carb or placing extra emphasis on that carbohydrate burning system to start expressing higher levels of that enzyme. That's probably how it works. At the same time, when someone is on a very low carbohydrate diet, they do there is this concept of physiological insulin resistance, in that what the body will do is it will actually place a block on pyruvate dehydrogenase. It will place a block on GLUT4 receptors. These are receptors which get glucose into the cells, and it will make cells physiologically insulin resistant, meaning that they can preserve glucose. So only if you've got a limited amount of glucose floating around in your blood, basically, and you're not getting it from the diet, you need to prioritize cells that can only use glucose, because we do have cells that can only use glucose. So erythrocytes, for instance, so your red blood cells. Your red blood cells can't make energy from fat, so you need glucose in that respect. Basically, you are going to preserve glucose for some of those tissues and cells that don't have any other option. And to do that, it will make the cells that don't rely on glucose, like your muscle cells, etc., it will make them insulin resistant. And that's not a pathology. It's just referred to as physiological insulin resistance, because that seems to be what happens in someone who doesn't have much carbohydrate coming in from the diet.
Right, but chronically, would that be like, how is that different than pathological? Isn't it the same thing taking place? It's just a matter of...
Mechanistically, you could make arguments for that, but you could also make arguments that in physiological insulin resistance, you can reverse it very quickly just by eating carbohydrates. Like within 2 or 3 days, you can reverse that and someone isn't insulin resistant. Whereas pathological insulin resistance, it's not going to present in that way clinically. I'm not saying that physiological insulin resistance is good. Like, I'm not on a carnivore diet. However, I do think that it has its therapeutic benefit without a doubt. Like, and there are certain people who do seem to really do well on it, and I'm not going to argue with that. However, my position is that if someone, I think carbohydrates represent availability and abundance, environmental abundance. And if you can burn them for energy, if you're someone who can't burn it for energy and it triggers you disease or something like that, then whilst you're working on how you can do that, I think carnivore or animal-based or keto, whatever, can really help. But if you can burn carbohydrates in a clean and efficient way, then I tend to think that people do better, or I see that people do better with that for sure. So coming back to your question, in your specific context, I think one of the ways that could potentially help that is that if someone has gone from a long-term position of being on a low carb diet, I think thiamine environmentally is tightly coupled with carbohydrates. We know that. Because it's the most important nutrient for carbohydrate metabolism, I tend to think that by giving the body thiamine, you're kind of sending it a message that it can also start to burn carbs again. And so a lot of the guys that I would see coming from low carb and they don't do very well with re-adding carbs in, they feel tired, they feel groggy, that kind of thing. By giving quite a large bolus of thiamine, on a regular basis, they tend to find that they do a lot better. Now, on the flip side, you might find this also very interesting, is I have a lot of people who are on like animal-based, carnivore, low-carb diets, and we're using thiamine, especially in my group. I have a group on Facebook, over 11,000 members, and I see a lot of people who are on the low-carb diet because previously they couldn't burn carbohydrate for energy. They have insulin resistance, neuropathy, something like that, and it tends to worsen it. They're taking thiamine for an unrelated problem, or they're using it for some disease process. And what they find is that when they start using thiamine, they get intense carbohydrate cravings. And so it does seem as though, at least anecdotally, when you give high-dose thiamine, what you're doing is you're stimulating those carbohydrate-producing enzymes. It's almost like your body starts crying out for glucose. It starts crying out for it. And some of these people feel really good when they eat carbs. They're like, oh my God, I haven't eaten carbs in 3 years. I'm really scared, but I'm getting extreme cravings. I haven't had cravings in years. What's going on? I'm like, don't worry. Eat some carbohydrate. They eat carbohydrate and they feel great. Whereas previously, if they hadn't taken the thiamine, they eat the carbohydrate and they feel terrible. So there is some environmental coupling there, and I'm not sure exactly what it means. There's an environmental coupling between carbohydrate and thiamine, and that when you give one, you tend to be able to do better with the other. That's all I see.
Gotcha. And full disclosure, Elliot makes products that are thiamine. And I applaud you because you make clean products, and I think I've heard you mention that you made it because it wasn't available. You wanted something and it didn't exist without a bunch of fillers or crap, and you made a good one. And we've definitely gone through a few bottles of it in my house, and now I'm exploring different forums and just trying to see like which is the best way for me. And I've my daughter's been tinkering around too, and I have some questions about that. Before we get into that, like how does somebody approach seeing if thiamine is useful for them? How would somebody maybe know? I mean, I would think low energy is like the first place that you might start, where you just don't have enough energy to do all the things you feel like you should be able to do. What are like the more common things that you see that people deal with where thiamine might play a big role in helping them get back on track?
Yeah, that's a good question. And really, we should you'd asked me a question before. I should have probably gone through the basics that the listeners know, but take it for granted sometimes. Sorry about that. Basically, yeah. So energy is going to be really central because we've spoken about how it is important for all of those steps of how you're breaking down the energy coming from food. But when we consider what I was talking about before, about how all of these different types of diseases have this mitochondrial component, as in mitochondrial dysfunction, if it occurs in the brain, you might have a brain condition. If it occurs in the skin or in the lungs or in the heart, you might present with a health condition in those areas of the body. Well, because thiamine is so central to how mitochondria work, it means that it can technically present in almost any different type of condition. I know that sounds a bit odd, me saying that. By conventional wisdom, it's going to be any problem with the brain, nervous system, so your neurons, peripheral neuropathy, how your brain communicates messages to the rest of the body. So if you have any problem with tremors or controlling your muscles, with balance, anything related to your nervous system, thiamine can potentially be involved in. The heart is another condition, or a severe thiamine deficiency can cause problems with the heart. It's called wet beriberi. And so any problem with the heart can potentially respond quite nicely to thiamine. It may not reverse it, but it may improve it substantially. And then finally, the gut, so the gastrointestinal system. And the reason for this, I believe, is because the communication between the brain and the gut is essentially neurologic. So you use neurons to communicate messages through what's called the vagus nerve. And this tells the gut what to do and at what time. So if people have IBS or they have SIBO or constipation or any reflux or anything like that, and they've tried different supplements, they've tried different diets and it's not improving, well, that can also respond to thiamine, and because it's essentially helping the brain communicate to the gut when it previously couldn't. So anything
is that because of the mitochondria within the neurons themselves, if they have them, or is that because of its relationship with like acetylcholine or like neurotransmitters?
Okay, that's an excellent question, and we don't know the answer. I've literally just written a paper on it with a professor from Russia, and she thinks that it is because of the cells in the intestine and the enteric neurons. I think because it is improving the communication between the brain and the gut via the nervous system. However, it seems that both might be true. It's hard to characterize. However, what does seem to be the case is that the gut cells, so your intestinal cells, you have what's called the enteric nervous system, which is like the second brain, they call it. And the cells of the gut seem to be very susceptible to a deficiency in thiamine. What that means is that the body will prioritize, if you only have a limited amount of thiamine coming into the body, it will prioritize the organs which are necessary for your immediate survival. So your heart and your brain, okay? And the heart and the brain are the last organs, in severe deficiency, they're the last organs to become depleted. So you can live with like thiamine deficiency in the muscle, in the gut, in these various areas. But if you develop severe deficiency in the heart or brain, you could die very quickly. So we'll preserve it. And so the evidence seems to show the body, if it detects low levels, will pump out thiamine from the gut cells, and the gut will be left with the final bit. And because of that, But it's also important, like you said, acetylcholine. Acetylcholine is a neurotransmitter. And what this means is that any issue that you have with memory, any issue that you have with cognition, with thinking, if you have anxiety, if you have any issues like ADHD or autism, all of these things can involve a lack of what's called cholinergic neurotransmission. So not enough of the neurotransmitter acetylcholine. And thiamine is needed not only for the production of that, but also for the release and the action of that. So really any problem with the cholinergic system can respond to thiamine. But I just want to provide a caveat here. If you look at some of the earliest studies of deficiency, they found that there's a controlled study. What they did was they had patients on 10% of the amount of the recommended daily allowance. So the daily allowance is 1 milligram per day. That's what you should be getting to prevent a frank deficiency. However, they found that in these patients, have on 10% of this dose for 90 days, they found that none of them developed the classical signs and symptoms of like peripheral neuropathy or heart enlargement or severe brain degeneration. But in fact, most of them just developed a non-specific set of really strange symptoms. One of them, like you said, was fatigue, lethargy, poor motivation, gut dysmotility. So all of them had like low stomach acid, reflux, constipation. Again, this is not considered a deficiency sign or symptom. One of the first things to come on. Likewise, they developed strange things like insomnia or rapid heart rate or slightly vertigo. So they lost their balance. They lost their motivation. They didn't want to speak to anyone. They just developed a wide range of symptoms that you wouldn't classify as any particular disease, but you would say, oh, I have X and X, Y, Z symptom. So that really demonstrated that ultimately, it can be very non-specific, and if someone is particularly run down or they have just nagging things, it could potentially respond to B1. Like if you look at some of our testimonials, some of the reviews that people on my group who've started taking high doses of thiamine, well, they say, oh, I started using it for this particular thing, so they have some neuropathy, but then they find that their skin issue also cleared up. They find that their chronic anxiety of 20 years also cleared up. So we see that there's just a wide variety of things that no one would suspect as being caused by deficiency in B1 that can actually respond to it. So I tend to be fairly hesitant to say, oh, these are the symptoms it can improve and these are the symptoms that it can't improve, if that makes sense.
Personally, I don't know if it's all from the thiamine, but one symptom that I had that I no longer have. Now, I've been tinkering with a couple things. So it's like, I'm an idiot. I do this so many times where I'll try multiple. I'm always like trying new things, and then if something works, it's like, well, was it this that worked? Was it that? Or if something doesn't work, I don't know. So I don't know if I'll ever learn that lesson. But I had like, I guess it's a form of neuropathy. I never had it checked out, but the top of my feet would be like kind of tingly. And like when you touched them, like if I, especially one foot in particular, there was both a little bit. One was more than the other, but like if you touch the skin, like it felt tingly. And that's gone. And I feel that is like, well, that's got to be really positive. I mean, because my guess is if that got better, other things that I don't even know about probably did. But the you mentioned motility thing, and that's why I was also wondering about its role with like the nervous system and acetylcholine, because from what I recall, acetylcholine kind of drives that autonomic nervous system and like the motility. Like I notice things move quicker, and it seemed like at a more healthy rate when
you take thiamine.
When I take thiamine. So I've been playing with some different things. So I've tried a few. You make a product called Thiamax, which from what I understand is a fat soluble. There's a couple forms that are fat soluble, a couple forms that are water soluble, and I felt good things from your Thiamax. This it's called TTFD. I'm not even going to attempt to. But you want to say the big words? What does that stand for?
Yeah, it stands for thiamine tetrahydrofurfuryl disulfide.
Yeah,
but we just call it TTFD.
Okay, so I tried that, and I've felt good things. I did have one symptom that I don't know if it's a positive thing, but I would get like a couple, I don't know, maybe like weird, non-typical pimples on my lower legs continually. But like the first few days because I will pulse it, like I'll try a bottle and then maybe a few months later, try a bottle. I'm not like suiting it. And when I start it, that happens. Now I do get positive things, energy related and such. And so I don't know what to do. So I don't know, like, is that a detox thing? Is that like I'm turning on systems and I'm pushing something out? But they're kind of like, I don't want to say hard or cyst-like, but they're like non-typical pimples. And I'll get like a half a dozen of them over the course of maybe a week, and then I don't get them.
Yeah, that's weird. Does it stop when you stop taking it, or do you carry on taking it and it just goes away?
Both. If I stop taking it, they'll go away. But if I keep taking it, it'll also go away. But if I go a month without taking it and then start again, I get it again. It's not like problematic. It's not bothersome. It's not like a histamine reaction where it's some kind of itchy rash thing. It's just like my interpretation is it's like my body pushing something out that it doesn't want.
Yeah, that's interesting. I would say if it only goes away when you stop taking it, then it might be an indication that it's not doing you too good, or that form isn't particularly suited to your physiology, and there's various reasons for that. However, if it goes away even if you continue taking it, then it could, I don't know. I mean, it could be affecting some hormone level. It could be pushing something out. We know that, okay, so there's different types of thiamine, right? Or there's different derivatives. And the reason for that, you will have seen if you watch my videos, probably, but it comes back, the story starts in Japan, right? And in Japan, they had, because they started polishing the rice in Japan, it became like a status symbol. So the higher classes would, white rice is a relatively recent invention that occurred like in the late 1800s and early 1900s. And so they were polishing the rice, taking away the brown bit, but the brown part was what contained the thiamine and the other B vitamins. So these high classes would consume a lot of this white rice, and they would induce a thiamine deficiency because they were causing this imbalance, like what we were talking about earlier. Well, because thiamine deficiency was so common in Japan, the researchers were searching, after it was identified and isolated and things, they were giving it to people, and they were finding miraculous recoveries from these health conditions. But what they found was that some people were very difficult to treat. And they learned that is because if you just isolate normal thiamine salt, so it's a thiamine which is bound to a hydrochloric acid, thiamine hydrochloride, they found that it was very difficult to get enough into their body to reverse the deficiency over in a short period of time. And that's because the body has these mechanisms by which it absorbs nutrients. It does this through what are called little transport proteins. And you have these dotted on cell membranes. So in the gut, if you take something orally, there'll be transporters, but these are what are called saturable. It means that there's a limit to how much you can absorb through those proteins, if that makes sense. Same thing occurs at cells. and also in the brain. So you could take 200 milligrams of thiamine hydrochloride, but you might only actually absorb 10 milligrams of that. You know, the estimated amount that you absorb through this transport is about 5 to 10% amount, 5 to 10% of the amount in which it's actually exposed to. So you're exposed to 200 milligrams in a supplement, you might only absorb 5 or 10 milligrams or 10 or 20 milligrams maximum. However, what the Japanese discovered in the 1960s was that you can synthesize, you can artificially add different molecular groups to thiamine and other nutrients, by the way, but particularly thiamine in this case. If you add different, or if you change the molecular structure in some way, you can trick that system. You can actually bypass it altogether. And the way that they discovered this was through looking at garlic. So garlic, when you press it down, what they found was that the thiamine in small amounts contained within garlic actually bonded with the sulfur in garlic, produced what's called allithiamine. And this allithiamine had very, very, very unique qualities in that the allithiamine could essentially, you think of it like this, basically dissolve across the membrane. So you have normal thiamine, which has to go through these transporters, but allithiamine just literally dissolved. What that meant is, in practical terms, you can get massive amounts of active thiamine into cells without having to worry about the dose, without having to worry about these transport systems. And therefore, you can get it into the blood really easily. You can get it into the cells really easily. You can get it into the brain. Since thiamine deficiency affects the brain, what they were finding is that when they give this type of thiamine to these patients, they recovered much faster, right? Because what might take 6 months sometimes took like 2 weeks.
What's the form of thiamine that is found in foods that have thiamine?
Yeah, so usually it's just the plain thiamine molecule. So it can be free thiamine, or it can be in the form that our body uses itself. So it's called active thiamine pyrophosphate. It's basically with phosphate groups attached to the thiamine. That's how we use it in our enzymes. However, the bioavailability of these are not very high. They have these transport systems. That's how we're getting it into the body. They have to go through these transporters, so they don't just dissolve. So this is kind of like an artificial way of getting very high amounts of a nutrient into a cell to saturate the cell. Going back to the Japanese, they discovered that there were, in fact, numerous of these different derivatives. Now, if anyone looks into thiamine derivatives, they may have heard of one of those. One of those was called benfotiamine. Benfotiamine is now a common supplement in the West. It's been heavily studied in the West. However, in Japan, they focused mostly on this allithiamine. However, allithiamine was very difficult to isolate, and it was very difficult to remain stable. So what they did was they slightly changed it, and they made what we now call TTFD. So TTFD is the closest relative to allithiamine, and it basically performs the same action. And they also made something called sulbutamine. So if you look at a lot of the research, benfotiamine does a similar thing. It also dissolves past the membrane. Sulbutamine dissolves past the membrane. So these three derivatives are very good ways for someone to get high amounts of B1 into their body. And as I said, the research...
Is there a risk of getting too much?
The good thing about thiamine is that when cells are saturated with it, there's no toxicity per se.
Will the body just excrete it through urine or something?
Precisely.
Okay.
Precisely. Yeah. And that's the good thing in that they have given massive doses of this to people long term with no toxic effects. Same thing as in animals. No toxic effect.
So how do you know when you get the right dose? Like, let's say you start low. I assume you can start low and then just slowly, like every week or two, increase the dose until the symptom that you're curious about goes away, or?
Yeah, that's generally the principle. Comes back to the work of Dr. Derek Lonsdale. He recently passed at the age of 100 years old this year. But he was the pioneer of thiamine in the West, and he came up with the principle of using it in high doses for different conditions based on what the Japanese were doing in the 60s. So what he found was that the way to start off is to go very low dose. So you might start at 10 or 20 or 30 milligrams or even 50 milligrams. And you would gradually build up the dose over time. What you'd also do is you'd use what's called a B complex behind it, because you have to think of vitamin B1, although it's very important for energy metabolism. all of the other nutrients are as well. They're a medley. They're an orchestra, as he would say. Lonsdale would say they're an orchestra, and thiamine is the conductor. What that means is...
That's what I've been doing. I've been taking a B complex and then an extra thiamine, and I'm playing with the salt this time, which I've never really done. I've only really used yours, and now there's a little bit in the B complex, but it's very little. So I'm adding like 100 milligrams of thiamine HCl. And then if I have like a big bolus of carbohydrate, I'm having one more. So maybe a couple days a week, I'll have a second pill. And so far, it feels good, feels positive. So I'm like, well, feels good. Will I feel better if I take more?
It depends. I mean, there's a limit to that, right?
I don't know.
What I say... So what I'd say is...
This is where my discipline doesn't serve me well. Like, I'm not good at this part.
So for the listeners, what's important to know is that the dose... There's not really any dose equivalence. What we do know is that to achieve the same effects on cell metabolism and organ function and neurotransmission, you generally need much higher doses of the salt form. So the salt form is the cheapest, and it could come in either thiamine hydrochloride or thiamine mononitrate. Whereas if you use one of the specialized derivatives, they're more expensive, but you need much less. So, usually what I like to say is that you could need anywhere from 5 to 10 times the amount of thiamine salts compared with the derivatives. Now, among the derivatives, there's also a difference because people tend to need more benfotiamine than they do TTFD. TTFD, you generally need the least, you get the most bang for your buck, whereas benfotiamine, again, it tends to be cheaper, it's much more readily available, but you do tend to need higher doses. So depending on what the health condition is, what I usually say to someone is starting low at like 50 milligrams or 100 milligrams, and you look at your symptoms and you say, okay, I've got these symptoms that I want to improve. You would start at, say, 50 or 100 milligrams. You use a B complex and you take magnesium as well. Magnesium is important, but also probably a full spectrum electrolyte. So something that also contains a good amount of potassium and maybe some calcium. So you've got this as your baseline. You're probably not, or a person is probably not going to see any change at 50 milligrams, but it's a good starting rate. Now, there is what is called the paradoxical reaction. Paradoxical reaction is when someone who needs thiamine presents with paradoxically negative symptoms when they start taking it. And that's sometimes actually a good sign. It's a good sign that the body is going to respond. And so the concept is you would start at a low dose and you'd see how your body responds. And you'll look out for any of the symptoms that you're trying to fix actually getting worse. So let's say you start with, you got neuropathy and you got fatigue. When you start taking thiamine, you might notice that your fatigue gets substantially worse. That is not a sign to stop. What all that means is you just do not increase the dose. The concept is you only increase the dose when you return back to the baseline that you started with. So let's say you start with your fatigue at a 5, your neuropathy at a 7. You start thiamine. If your fatigue goes up to like a 10, then you're going to completely wait. You're going to hold back and you continue on that dose until your fatigue gradually returns back to the baseline, which was 5. If that makes sense.
Why does that happen, though? Like, I could see how that would be a real obstacle for somebody if you start to feel worse.
For sure is. It's a sign that the body has had too much. There's various theories for why. What Lonsdale suspected, and I think he might be right, is that if you have, like, substantial enzyme inhibition, you remember what we're talking about with these machines, like you were mentoring? What if these machines get rusty? Well, that's what Lonsdale suspected, is that if these enzymes were running at such an impaired rate for such a long time, well, the expression might be not be very high. So what you're doing when you're sending a signal to the body, when you take thiamine, might be that you're telling the body to start making new enzymes. It's like replacing all of its defective machinery and replacing it with brand new machines that are ready. They've got much higher output. You imagine you have like a warehouse where you manufacture goods and you've only got like 3 machines and they're really rusty. Well, you just get a massive injection of a lot of funding. You get like 20 million in funding. You're going to start investing in like 15 million worth of the highest tech machines. Well, to do that takes time. And that's what, Lonsdale suspected might be the case. When you start thiamine, you need to give your body a little bit of time because it has to adjust to the amount of a nutrient that it's been dying for a long time. Now, what you might also see is changes in nervous system. So you might see like changes in the heart rate or changes in, body temperature. You might notice some dizziness, this kind of thing.
Really, body temperature. That makes me think, so increasing in body temperature, I would assume?
It can be an increase or a decrease.
Have you ever had people, I have 3 questions left. Have you ever had people, Elliot, that measure their thyroid panel and then add thiamine and nothing else and see thyroid function elevate?
I've seen an improvement in the reverse T3 measurement.
So like a reduction in reverse T3?
A reduction in reverse T3. I've not seen any explicit changes in thyroid hormone. However, what we do know...
Well, that would be telling, because isn't that... if that goes down, holding T3 constant, that would mean you have a pro-metabolic effect, I would assume.
Yeah, of course. And that's thiamine and thyroid have a lot of overlap. In fact, many of the symptoms of thiamine deficiency, not severe, but mild, have a substantial overlap with hypothyroidism. And we have evidence, there's case studies looking at high-dose thiamine in hypothyroidism, showing that it can reverse the fatigue in that condition.
Really? Do you know what doses and what forms they used in those?
So they use thiamine hydrochloride from what I understand. And I think the dose was between 500 milligrams and 1,000 milligrams per day. However, we have a lot of anecdotal evidence from people on my group and in the various communities who are using high-dose thiamine, who use derivatives like benfotiamine and TTFD, and they find similar results at lower doses. Now, there's the thyroid pharmacist. She's written several books on thyroid. Her name is Isabella Wentz, and she's seen remarkable results with some of her patients and herself using benfotiamine. I've seen very good results using other derivatives as well, or a combination of all the derivatives.
What's the name of the group again? How do people find that?
My group, yeah, so it's called Addressing Thiamine Deficiency and the Paradoxical Reaction. And it's where basically people who, like yourself, come across my videos or read my articles or something, and they want to get in contact. I don't do consultations at the moment. I had a year-long waiting list for the longest time. So I figured the best way to get hold of me is people can actually just ask questions on there. And there's a lot of veterans who have gone through the process and they stick around, bless their hearts. I don't always have the time. I can't give direct health advice. What I can do is answer in an educational way. Now, a lot of people on there have gone through this and they've come out the other end. And if you just go on there and type in testimonials, you see all of the people with different conditions, and many of them have seen substantial improvements in their what they considered to be health problems caused by hypothyroidism, whereas actually they may have reduced the thyroid antibodies and they have good numbers, but they still have the symptoms. So I think that there's a real overlap in terms of people who respond to thiamine and people who are functionally hypothyroid, let's say.
Okay, that's very interesting. My daughter requested a question, and well, it's my daughter. I have to ask you, Elliot. So she took the TTFD, the Thiamax, and she had a sulfur taste in her mouth that lingered for like a day or two after one pill. And she didn't feel bad or anything. I think she might even mention that it felt supportive. What's going on there? What's going on there? Have you heard anybody say that?
It's frequent, and to some extent it's normal. It's actually one of the main reasons why they phased out. They originally came up with an allithiamine derivative, something which was similar to it, called prosultiamine. They originally phased that out because people who took it got all of the benefits of the allithiamine. However, they stunk out the entire room. Like they didn't even want to leave because they were just emitting this sulfur garlic smell, and they could taste it and it was coming out of their pores and they would stink, and people wouldn't want to take it because of that. So that's why they changed the molecule and synthesized TTFD, which we have in Thiamax. However, it still does have some elements of that. Like, for instance, if you take a high dose of TTFD and you get a sweat on, you can sometimes smell it in the armpits. Some people have it kind of on their breath. And what it's likely reflective of is the sulfur compounds contained within the TTFD. So TTFD, in simple terms, the molecular structure of it looks like this. It's a thiamine molecule, and then it's this what they call a mercaptan. It's basically something similar to what you would find in the sulfur chemicals of garlic, because it originally derives from garlic. And so there is this garlic odor or this sulfurous taste. Now, some people don't find it problematic. I personally don't have an issue with it. I quite like it because it's only there for like an hour or two after taking TTFD. I don't have an issue with it. Some people really hate it and they have it for like days afterwards. Now, I think it probably relates to someone's. It could be their nervous system, like their olfactory system in some way. Their olfactory is that the taste and smelling. Yeah, they're connected. I think
there is what's called the olfactory test, which is they use TTFD to test whether someone's olfactory system even works. So they have been doing that in Japan. I think it might have to do with genetics in that regard, or what it could be due to, and what I see some people improve it with, is improving overall metabolism of sulfur compounds. So what you find is that people who have chronic health issues, many times there is an impairment or a blockage or some kind of a disruption in how their body metabolizes sulfur. And these people can oftentimes react negatively to, say, garlic, onions, other sulfur-containing supplements like NAC, MSM, these kind of things. These people can sometimes have reactions to those as well. And what that is often reflective of is impaired sulfur metabolism. So what will happen is they'll consume those and their liver and cells can't properly break them down. And so they end up filtering into the blood and they stick around for a long time, and it takes someone's body a long time to get rid of them.
It's funny because I could eat a tablespoon of MSM at a time.
Yeah, and you're good with that.
Yeah, it seems to be supportive. I don't take doses like that anymore, but I was in a phase where I did. It was interesting. So does that mean maybe that she is missing things that you need to support sulfur metabolism? Or could it be just a genetic thing? Or
it could be either. What you find is that oftentimes it does improve over time as their body starts to get used to the sulfur compounds. It could be genetics. I dug into this a couple of years ago. I think that there's a CYP system. CYP, these enzymes in the liver, which are responsible for biotransformation of different what are called xenobiotics. So these are environmental compounds or chemicals. And some of those are involved in how you break down compounds in garlic. And I think that they're very similar. If you look at the breakdown of TTFD, it produces very similar compounds that you find in garlic. Now, they're not toxic. They're not toxic. And in fact, some of those compounds actually seem to have antioxidant activity, so they can protect cells. So it's not necessarily a bad thing for the cells. However, it can be an annoyance. In that case, I would say maybe molybdenum can in some cases be helpful, because that improves the metabolism of sulfite to sulfate. And I think if there's a backlog in that pathway, then you can end up with higher amounts of these sulfur compounds. I would say if it persists over, the space of several weeks or even a month, and it doesn't improve,
she's not going to last that long.
No.
She's 20. She's like, yeah, that's not going to work, Dad. I'll try.
Yeah. No. So in that case, I would simply switch to benfotiamine if it's something that she can't deal with. Most people they'll just deal with it because it's like a bit of an annoyance. And the benefit of the compound helps them so much that it's like it's completely irrelevant. Whereas if it's someone like in your daughter's situation, I would simply switch to benfotiamine or maybe even sorbutiamine because it doesn't necessarily have that effect.
Last question. If somebody, it's great that we have these tools, these options of different supplements, and I'm definitely one to tinker with supplements. And I also know people that really look to try to optimize their diet first and look at supplements really as a last resort. If somebody wanted to focus on food, what are the foods that stand out, or how should they approach their nutrition to try to maximize their thiamine status, I guess?
Okay, great question. Well, thiamine is ubiquitous in food. What that means is it's found in most foods, as are most of the B vitamins in varying degrees. Particularly high in some random things like asparagus, super high for some reason. Really any animal food. So that's going to be organs, particularly your liver, but also muscle meat.
So all parts of the animal?
Most of the parts of the animal, maybe not the skin, not the fat, but the muscle. And that is because animals, like humans, we are technically mammals. And so they need the same vitamins that we need. So eating animal foods can give us a lot of what we need because of that.
Because they're using thiamine for the same function?
Yeah, exactly. Yeah, they have the same mitochondria. They have the same processes. So if you look at how, a pig or a mouse makes energy from glucose, it's going to be the same as how we make energy from glucose. Because of that, if you eat meat, you get a lot of actually what you need. But it's, like I said, ubiquitous. I think the best way to protect against a deficiency is to eat anything that contains whole, anything that's whole. Okay? So if you're going to eat grains, I know that there's a little bit of a debate around this because of the anti-nutrients and things, but for instance, if someone was going to eat grains,
from a thiamine perspective, it would be best to consume a whole grain. Now, I don't necessarily recommend that, but from that perspective, anything which is whole or unrefined is going to be your best bet. However, on the flip side, I think a much more practical perspective is to limit your consumption of refined carbohydrate, fat, protein. So that means if you eat processed foods, chances are you're going to be putting yourself at a major risk for a deficiency. That also means if people like among the repeat community who think it's a great idea to go and eat shit tons of white sugar, well, you should really be supplementing with a whole body of nutrients. You should not.
But you said organic or whole cane sugar earlier had some. Is that probably a phenomenal?
Again, when you process, because nutrients are sensitive to heat most of the time. Thiamine is sensitive to light, for instance.
What about fermentation? Like if you make sourdough bread.
Okay. Now that's a good point. That's probably going to be a good source. In fact, nutritional yeast is an excellent source of all the B vitamins. Yeah, nutritional yeast. So some people use nutritional yeast, but really avoiding the processed the processed foods is going to give you like 90% of, going to put you 90% of the way there. Another thing is to really watch your alcohol consumption, because alcohol directly blocks the activation and the absorption and the utilization of B1. And that's why alcoholics, the main deficiency that they will present with is thiamine. So avoiding alcohol consumption or really limiting it, or if you're going to consume alcohol, that's not necessarily a problem. But if it's a regular thing, then you need to be supplementing with thiamine. That's non-negotiable.
Yeah, I think I did a lot of damage with the alcohol abuse over so long that I'm like just trying to still dig my hole out of them.
So many people do. And really, you can find that, alcohol, a lot of the problems can be mitigated to a large extent. I mean, there's so many people who drink alcohol very frequently, but with just a little bit of liver support, get some TUGCA, phosphatidylcholine on board, some, milk thistle, a bit of artichoke, and then some B vitamins, you can mitigate most of the damage of alcohol. Like, I'm not against alcohol. I drink alcohol. I don't have a problem with it. I'm a problem with being a slave to alcohol, and I'm a problem with consuming alcohol in frequent amounts without trying to mitigate the effects. I think it's probably best if it's left to an occasion. But, if it's something that you don't have control over, you need to take the steps to mitigate the potential negative consequences of that. That's all I'm saying,
Elliot, thank you. Got some selfish questions out of the way. Got a lot of information. I know we got a little nerdy there, so hopefully people hung in through that, even if it didn't register. So you mentioned your Facebook group, Addressing Thiamine Deficiency, and what was the rest of that? It was longer than that.
Yeah, Addressing Thiamine Deficiency and the Paradoxical Reaction.
Okay, and how else can people find you, connected with you, or?
Yeah, so I'm on Facebook. I use it primarily to run the group. I'm on Twitter. I don't really use any other social media platform. I like X at the moment. I am also on YouTube. That's how most people find me. It's EO Nutrition. And I haven't posted for a while. I've been super busy, but at one point I was posting kind of once every couple of weeks or something. I plan to get to that very soon. So on there, I talk about lots of different topics. I've got probably 60 or 70 videos on thiamine now. And I do a lot on there with regards to nutrition and health. And those are the main ways. You see my website, it's currently under construction, but it should be available soon. That's how people can get hold of me.
Sounds great. For the listeners, I highly recommend, if you want to learn more, binge on Elliot's content on YouTube. It's a great resource. And again, I appreciate you putting it out there for the public. And looking forward to checking out the Facebook group. And I could probably just search different conditions and things and find, that would be an interesting resource, I bet.
We have people from all walks of life on there who have managed to address many so-called incurable conditions. We've got people with multiple sclerosis, people with Parkinson's, people with inflammatory bowel disease, which are in remission. We've got all kinds of people who are, it never fails to amaze me what can be achieved with one single B vitamin when it's used in a high dose and in a protocol. And again, I'm not trying to sell anything here. The testimonies speak for themselves. You just go on that group and you look at the benefit that some people have managed to have, because they've been let down by the conventional system.
Yeah, and vitamins are a big deal. Vital amines, they are vital.
Yeah, for sure.
You know, they're named that for a reason. And there's a reason this one came up first when they were looking. Elliot, thank you again. I appreciate it for taking the time. And for the listeners, always grateful for your listening. I hope you enjoyed this conversation, and I encourage you to check out more if interested. I hope everybody has a great day.